All right, welcome everyone. Say hi. All right. So we are back from AWS. I'm a solutions architect with AWS, working with enterprise customers, specifically with media and entertainment industry. And today I'm very, very thrilled to be joined by my colleague, Kenny.
Yeah. Hey everyone, Audible as well. I'm Kenny, also a solution architect here at AWS, working alongside with Nishant for our enterprise customers, but recently moved to the ISV team, which is our individual software vendors. Very excited to see all of you here and to share something on Strands Agent.
Lovely. Cool. First of all, thanks to Chris for really, really invaluable insights on how one should be using these large language models and generative AI overall responsibly and authentically. But there are so many use cases out there which are really, really positive and making a difference on human lives, medical sector, finance sector, and whatnot. I want you to focus on those good use cases for the next 30 minutes of our session. So, first of all, give you a big, big round of applause, not just for organizers and speakers, for yourself, because you showed up. You showed up. You care. It means you care about connections, networking, and knowledge sharing. Cool. In today's session, we will be talking about how builders and developers or AI/ML engineers can quickly build those agents and make them production ready in just no time. And before we get started, I think what we need to cover is, yes, we will be having some cool demos and quiz. We have got some really cool AWS goodies. Of course, we brought them with us from Sydney. And you will be rewarding top 3 winners of the quiz, so stay tuned. Will be a quick knowledge check on how effectively you listen to all the knowledge that we shared with all of you. Cool, let's quickly get started. If we talk about agentic AI today, if we talk about generative AI agents, every organization, from financial services to healthcare, every organization is thinking about them. They are not thinking just about creating a POC, they're also thinking about deploying them in the production environment. Even Gartner also predicts that 33% of enterprises will be embedding these AI agents into their software applications, which is a significantly high percentage from less than 1% in 2024. It would not be wrong. It would not be wrong if I say we all will be working and operating with agents in next 12 to 24 months of time. It's a good opportunity, massive opportunity for all of us to learn this new technology and make our work more effective and influensive and impactful for our customers. Cool, and I think you already know about what AI agents are. AI agents are nothing just a software program which talks to the tools, databases, servers, think, plan, reason, and get the job done autonomously and independently based upon the reasoning capability of large language models. Next. Wish I could have the clicker.
Oh, the clicker's not.
Right. Yeah. Had you put that?
Not yet.
All right, no worries. Cool. So when we talk to developers say we want to have really good flexibility while building those agents. We want to have deeper visibility into how agent is talking to large language models. What about traces, metrics? What happens when we deploy the application to production or agentic application to production? How they are talking to different tools and mission critical databases of your enterprise industry, right? And they're also afraid to commit time to learn a new software framework. They want a very, very easy framework to get started, right? So by considering all those challenges in mind, Amazon came up with Strands. Strands SDK is an open source SDK that takes the model-driven approach to build those agents in just very, very few lines of code. You can plug in your MCP servers, you can invoke other agents. We'll see it in a bit. Next slide. Think of agents, they are there somewhere in your application, and application is hosted somewhere in containers, on-premises, or virtual machines. Now the question is, you have an agent, it is talking to large language models. Question is, where is this large language model hosted? It can be hosted at on-premises, it can be hosted at third-party vendor, it can be hosted on Amazon Bedrock or SageMaker, anywhere. That's the flexibility Strands give it to the AI/ML engineers who want to build those agents. Let's take a look on what all tools and servers you can plug in with Strands. You can plug in your MCP servers. You can talk to your MCP servers over streamable HTTP, server-sent events, standard input-output, and you can also customize all the MCP protocols if your server supports a very specific protocol to which you want to talk through the agent. Second, it also comes with some inbuilt tools like current time, calculator, AWS services, how you perform operations on your AWS services and resources with the API, right? And the third, it also supports invoking other agents. When Strands agent talk to other agent, the communication goes over A2A, agent-to-agent protocol. So that is also something that is supported, and so many of our essays in AWS have built some POCs invoking Amazon Nova Act. This is also a large language model agent that performs actions in the browser on your behalf. So they are calling those agents with the help of the Strands agent from the application code. Cool, let's get to the next slide. Look at this example, just 4 lines of code. Nothing different than any standard SDK. You are importing some libraries like Strands, importing agent from the Strands library, importing some tools like calculator from Strands tool, defining the agent, and invoking that agent with a prompt. Right? Very, very simple to get started. Next. Woohoo, most interesting part, demos. So before we get into the demos, let's first understand what we are going to cover in this one. So this whole sample application is built on, This whole sample application is built on appointment booking application where you are defining an agent, and this agent is talking to 5 different tools. Out of that, you can see 2 are built-in tools and 3 are customized tools, which the user has defined these tools themselves, consisting of some business logic, talking to SQLite database in this very particular example. And SQLite database, it's an in-memory process database where it's not running anywhere, somewhere in the software libraries in the local environment, just for the demonstration purposes. And it is talking to a Bedrock hosted model, which is Claude from Anthropic in this case. And if you look at the right-hand side, this is the implementation. And if we expand it in more details, let's see how we can define those agents and the tools. Look at the system prompt. I'm giving it a prompt, hey, you are a very helpful assistant that helps me with booking my appointments by looking at these many number of tools like current time, calculator, and some 3 other tools which helps or insert the record into database and helps me with my appointment preferences. And once you are done with inserting the record, give me the appointment ID so that I can make some changes whenever I need. Look at the first 2 tools. These are some built-in tools which comes out of the box with Strands. That's how you can import them. And last 3 tools are some customized tools. And interestingly, you can also define your custom tools with the help of tool decorator. I want you to focus on this decorator at the rate tool. You can define your tools into different files. You can define your tools into the same coding file or can follow an industry standard or AWS recommended standard for your production ready applications. It's called tool spec. You can read about that in our Strands AWS documentation. Next, let's look at the demo. In this demo, I'm using the Streamlit framework, which is a Python UI framework to build some UI for AI/ML workloads or resources. So I just give it a prompt like, hey, what do you do? It came up with some suggestions and say, like, I'm an appointment management tool. I have access to these many tools. And if I give it a prompt, cool, I'm Nishant Dhiman, an SA, working at AWS. I have a session in Brisbane Community Center on 15th of August at 2 p.m. And I'm also meeting some partners, book an appointment. And let's see what it did exactly. I didn't tell which tool to use. It is going to independently use the tool which is suggested by large language model. It automatically chose create appointment. I didn't tell it. I didn't hardcode those tools myself, as an like hard-coded workflow that we used to build. And it just inserted the record in the database. And next, I'm giving it a prompt that, hey, tell me what all appointments do I have next week. And it doesn't know which next week the user is talking about. Guess which tool it is going to execute first. Current time. I didn't say it like use current time tool. Model told agent use current time to calculate which next week user is talking about. Calculate the current time, calculate the next week, which next week, and then run list appointments from SQLite database to list all the appointments that user has for the next week. And it gave the response. Isn't it really cool? We do not need to define any hard-coded workflows like we used to do traditionally. Now we are relying on these, agents are relying on these reasoning and reasoning capability of large language models to define or to choose which tools to use for a particular use case, which users want to achieve. Next. Let's understand what happened behind the scene. User came in with a prompt, and it gave the prompt like, hey, book the appointment for the next week. It's like it's talking to the agent somewhere in the application. Give it a prompt like, hey, book the appointment next week. This is the tools which I have the access to. Yeah. And large language models hosted on Amazon Bedrock, which is Claude 3.7 in this case, doesn't know which next week the user is talking about. Bedrock model told agent, use current time tool and run it, give me the output. Agent goes back, run that tool, calculated the current runtime, tell the model that, hey, this is the current runtime, now run this tool and calculate the date range. Okay, now I have the current time, I'm gonna calculate the date range. Here is the date range. Now, to list the appointments for the next week, you have to execute this query or list appointment tool with this date range and ask agent to run that. Agent runs that and gives the output to the model. And model says, cool, all right, now I have all the details which I needed. I'm going to create a professional response for the end user to finally render it to the user. All right, so that's how the final response is rendered to the user. Now with this, I would like to import Kenny from Nishant and Kenny SDK to talk about observability and deployment part of Strands SDK.
Cool. Thanks, Nishant. That was such a cool demo. I always wanted to have like a personal assistant, just can read your email and book appointment just literally at your fingertip. That was so cool. We did say at the very beginning that we're using the two strands of the SDK to wave production-ready AI agent systems. So any good production system can't go without a good observability and evaluation system. The number one challenge that we see from moving an AI agent from proof of concept or POC to production is, you guessed it, observability and evaluation. When we talk with our customers that is struggling with production development, it's always almost the same issue that they're facing. They don't know what's going on inside the agent. They don't know what's going on in their head. Well, the good news is Strands Agent solved that out of the box. So from day one, we have industry standard comprehensive observability built into the framework. So you get open telemetry traces in industry standard format. And you get complete metrics on token usage, on latency, on tool usage, on the event loops, right out of the box. So what does that mean to you practically? Next time when your customer asks you, what's going on, why is my agent so slow, you don't have to guess anymore. You immediately know where the bottleneck is. If it's a tool call that is consuming too much token, if it's the agents decided to run one single function repeatedly, you can then optimize your system prompt accordingly. And Strands integrate with powerful open source tools from day one. You can use Ragus for comprehensive metrics and LangFuse for tracing. In LangFuse, you will get a beautiful dashboard for visualization as well, which also means you get actionable insights rather than just raw data that you have to dig through. Again, this is production-ready observability built into the framework, not bolted on later. So you can debug faster and then deploy it with confidence. Speaking of deployment, what about the deployment flexibility? This is where Strands Agent truly shine. You can start by building your agent or test your agent fully locally. You can run it on your laptop, you can build it, import tools, build tools locally. You can have cloud-hosted models, you can have locally hosted models on Ollama. But then when it goes to deployment, this is where it becomes powerful. So imagine you have a client app, and then it's calling the agent via API, and then the agent is also invoking the tools via APIs. You might be seeing a pattern here. If it's all API calls, it's so easy to decouple them into separate environments. So let's say this is the user's environment, this is the agent backend environment, and then you have the tool backend environment. And if the client app is just like an app on your laptop or a mobile phone, then you can deploy your Strands backend into any platform, such as AWS Lambda for serverless compute, Amazon Elastic Container Services, or Kubernetes Service for containers, or Fargate for serverless version of the tool. And then I just want to quickly mention Amazon Bedrock Agent Core, which was just released in preview, purposely built so that you can build, deploy, and operate your agent securely at scale. And your tools, backend, can be run or deployed in a completely separate environment. Think about MCP servers, remote MCP servers. Think about Lambda package tools or distributed microservices. And those can be run or deployed in the same set of services on the screen. But now you've just turned your agent and tools into APIs or MCP servers that your client app can invoke seamlessly. Why does this matter? Tool reusability across multiple agents. So if you're building an agentic system at scale, this then becomes your competitive advantage. Again, this is open source framework, so expect the integration to expand rapidly. You can mix and match. There's a lot of deployment options. You can have backend agents calling backend tools, calling local tools, calling tools that's hosted on a cloud environment. It's all up to you. All right, another demo. So who doesn't want more demos? So in the second demo that we're showing a agentic loan underwriting application or home loan refinancing application. So we have two set of options here. We have the manual assessment and then the AI assisted assessment. Don't worry, I'm not going to click the left one or on the right, the manual one. We're not going to let you read 20 documents with us on the stage. So we're going to focus on the AI assisted one and to see how AI agents can help you to review the documents, validating the data, and then giving you a final lending recommendation. So this whole AI-assisted assessment consists of a hierarchy of AI agents that is working together, showcasing another very important feature of Strands Agent, which is multi-agent collaboration. So you have the supervisor agent here, that is orchestrating the entire process that has the whole context of what you want to do. And then you have three specialist agent, the income agent, the expense agent, and then also the credit agents that can perform domain-specific tasks, and then get back to the supervisor agent for final lending recommendation. The whole process kickstarts when the supervisor agent receives a loan application. And then the supervisor agent has a set of tools that can help the supervisor agent to gather important information like the application detail, the loan specification, the payslip, even unstructured data like extracting the monthly income, etc., and then passing those documents to those specialist agents so that they can perform their domain-specific tasks. With the Strands agent standard output format, then the specialist will be able to return these final output in a standardized format back to the supervisor agent, and then finally the supervisor agent synthesize the entire document and then give a final recommendation. Let's see that in action. So if we click on the AI-assisted assessment, on the left-hand side, we have in real time showing the agent's reasoning, response, and then also the tool use. In the middle, we have the section showing which agent is active at the moment and which tools are being called. On the right-hand side, we have a set of documents to show you those supported documents as a reference. We're also utilizing a very powerful tool called Callback Handler to show you all the reasoning and the responses in real time. So, like I said, the supervisor agent will be able to collect all the documents, give it to the specialist, collect all these answers back, and then finally synthesizing a final recommendation back to the user. So now the supervisor agent got everything, and then now can generate a final response. So if we click on the review recommendation, this final page shows you a comprehensive view of the final lending recommendation, including those specialist suggestions on why or the reason behind these suggestions, or some of the good and bads, so that the supervisor agent can decide, or the human underwriter can make an informed, transparent decision. And all you need to do is to click accept or reject. All of these are done within 90 seconds. And if it's not doing that in that time frame, you might run into issues. That's why you need observability and the evaluation that I mentioned previously to identify where the issue is. Cool. Now into quiz time. We did say that there's going to be a quiz to see if you're paying attention. Please join with the QR code here.
Oops, I'm not seeing the screen.
The screen.
Maybe you should click that.
Yep.
Yes, perfect.
And then I will.
We'll be really quick.
Yeah.
Give a thumbs up when you have joined. All right.
Okay. A lot of names.
Amazing. A lot of people.
Yes.
More people. 50. Amazing.
Amazing. Awesome. We'll just give another 10 seconds.
10 seconds.
Okay. 10 seconds. Cool. Seems like it stopped. Oh.
No. Some are still joining.
Cool.
Let's wait.
By the way, you'll get a prize if you come.
Yes.
Yes.
We specially
Top 3.
brought for you from Sydney.
Yes. All right. Let's kickstart. 65 people. Let's go.
Yes, 65 looks like standard ones.
What are the 2 strands in Strands agent?
Definitely not the 4th one. What are the 2 strands in Strands agents?
DNA, LLM models, metrics, traces, or maybe it's Nishant and Kenny.
Co-speakers. We are co-speakers. We are not strands.
All right, no one picked us. Okay, That's a bit sad.
Fun.
Cool. LLM models and tools. Nice.
Okay, I'll read it out. Which framework does Strands agent support for transmitting traces, metrics, and logs from day one?
Is it
We talked
closed
about
telemetry? Is it LangFuse? Is it Ragus? Or open telemetry? Okay.
Ooh,
And we do have some closed telemetries.
it was a difficult one.
Very interesting. Let's go to the next.
Strands agent requires the model to be hosted on Dash. Choose the most accurate response. It could be on Bedrock, locally hosted using Olama, SageMaker, or
All of the
all of the above. Could be an easy one. I always chose a particular one when I saw these kind of questions in my school exams.
Or I just choose C. Cool. All right, all of the above. Nice. Fourth one.
How can you deploy your Strands agents? What are the choices you have?
Lambda, ECS, EKS, Agent Core, all of the above again.
I don't know, we have two questions. Similar questions.
Maybe making it easy so that everyone can get some prize.
All right. 93%.
93%, all of the above.
Well,
Learning from the last question.
what are the key elements involved in an agentic loop? I would be so glad if you choose the right option for that, because my part covered that specific topic. What about coffee debugging? Ask AI agents for debugging.
For more debugging.
Ooh. All right. Okay, some chose.
Yep.
One or two
Cool.
people chose.
All right,
last
let's
one.
see.
Okay. That's fun.
Tamara.
Tamara, not applicable to
Okay.
you. Come on, Tamara belongs to AWS. Is it the same Tamara? Tamara, we got you.
We have Tamara in the crowd.
Congratulations, first three winners, Tim, Iwa, and Sin Natch.
Yep.
Thank you, and many congratulations for winning this one. Please meet us right after the session, and we will hand over these goodies to you.
Yep.
And let's quickly take a moment to quickly proceed with the session.
Yeah, so-
I would like all of you to take the photo of this particular slide. This has really key QR codes that you may want to refer after this session to get started with Strands, some workshops, some really cool documentations on SDK and samples on our GitHub repo.
Yeah.
They
You
were built
wanna-
by open source community. They were built by AWS specialists.
Yes.
Yeah.
Want to build your first personal assistant? Check out the sample. Cool. And
Please
give
submit the
us,
feedback for the
feedbacks.
session. How it resonated with you. And once again, thank you for showing up and giving us your time and listening to us. Thank you.